Hello there everyone, hope you are safe in this pandemic situation. I am Ahmad Shauki.
I am Taziran Munsha.
And today we'll show you how you can determine the nth term of any cubic sequence. In the previous video, we have shown you how you can determine the nth term of any quadratic sequence, and this will be the following part of our previous video. So if you haven't watched the video yet, I will highly encourage you to watch that before this video because the concept will be pretty much similar. And by the way, we have shared our story in the previous video, so without wasting any time, let's jump into the math exploration. So first of all, let's take the easiest cubic equation, and that is n cube. If we calculate the sequence for this equation, we'll get 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, and so on. You can rewrite this like 1, 8, 27, 64, 125, 216, and now let's work on this sequence. You need to figure out the differences of each sequential elements, and then you will get 7, 19, 37, 61, and 91. We have to do this a couple of times more, because in a cubic sequence the differences eventually matches up in the fourth row. Kindly focus on this process for a bit because we'll repeat this process multiple times throughout the entire explanation. We have done this in our previous video as well, so I will suggest again to recap the previous video and try to understand the methodology of finding the logic and thinking backwardly, so you can pause and ponder. Okay, until now you have understood that our main mission is altering the 4 rows of the sequence. So let's just continue our exploration. So one way to alter the rows is just adding a constant after our equation. In fact, we can just simply put +1, and then let's calculate the 4 rows one by one. We can see that the first row is changed but others aren't. Not only 1, but we can also add 2, 3, 100, 1725, or in fact any constant with our equation, and we'll be able to alter the first row. And the value of the first row will be equal to the old first row plus the constant. Now what will happen if we add a term which changes according to the value of n? Let's figure that out. Now we'll calculate the 4 rows of this equation, n cube plus n. We can see that now the first row is again changed, but most importantly now the second row is also changed. We can alter the second row by changing the coefficient of n, and the value of the second row will be the old second row plus the coefficient of n. Alright, now let's see what will happen if we change the coefficient of n squared. Currently the coefficient is 0 because we haven't used that term in our equation yet. Let's calculate the 4 rows of the equation n cube plus n squared, where the coefficient of n squared is 1. Now you can see that not only the first and the second row but also the third row is changed. So another achievement is unlocked for us. We have figured out that altering the third row can easily be done by changing the coefficient of n squared. And the value of the third row will be equal to the old third row plus 2 into the coefficient of n squared. Alright, now we have 3 logic, but in the cubic equation we need to alter the 4th row as well and figure out our 4th logic. So far in this video, we haven't changed the n cube term, though it is the most important term in the entire equation. So let's change it and see what happens. Instead of using 1 as the coefficient of n cube, we will use 2 as the coefficient of n cube, and let's calculate the 4 rows for the equation of 2n cube. Now we can see that the fourth row is altered. We can use 2, 3, 100, 1725, in fact any coefficient of n cube, and we'll be able to alter the fourth and the final row, and the fourth row will be equal to the old fourth row into the coefficient of n cube. If you explore this type of equation a bit more, you will eventually figure out that the value of the old fourth row will be equal to 6. So we can rewrite this equation by 6 into the coefficient of n cube. Now you may wonder why the fourth row will always be equal to 6. Well, we can prove this in many ways. We can either generalize the entire process using algebraic equations or differentiate the cubic equation 3 times. Since in the previous video we proved that using generalization, this time we will go for the differential calculus. So here we have a general cubic equation, ax cube plus bx square plus cx plus d. This equation here represents all the cubic equations. Let's differentiate this. We got 3ax square plus 2bx plus c. We need to do this 2 more times. Now you may ask, why should we differentiate the equation 3 times? We need to do this because here each equation represents each row. Since we have 4 rows, so we need to differentiate the first equation 3 times. Alright, now we can see that we got 6a after differentiating the first equation 3 times, which is the value of our new fourth row. Here a is nothing but the coefficient of n cube. So kudos to all of you. Now we have figured out each and every logic that we need to use. Let's recap those logic and connections. If you want to alter the first row, you have to change the constant of the cubic equation. Similarly, the value of the second row depends on the value of the coefficient of n. If we can change the coefficient of n square, it will eventually alter the third row. And finally, if you want to change the fourth row, the coefficient of n cube needs to be changed. Now that we have understood all the connections, it's time to reverse engineer the process and determine the nth term of any cubic sequence. Let's take a cubic sequence for example purpose. 0, 1, 0, 0, 4, 15. Now we have to find the equation for the nth term. But before that, how can you be sure that this is a cubic sequence? Well, you can determine that by finding the 4 rows of it. If the elements of the 4 row matches with each other, then it is a cubic sequence. So let's figure that out. Alright, since we have the value of the fourth row, which is 3, let's calculate the coefficient of n cube using our logic number 4, and that is the fourth row is equals to 6 into the coefficient of n cube. After some calculation, we will get the coefficient of n cube is equals to 1 by 2. So the first term of our equation will be 1 by 2 into n cube. For figuring out the second term, we need to calculate the 4 rows of 1 by 2 into n cube sequence. Alright, here the third row is most important because it will be going to be the old third row in our logic number 3 equation. Our logic number 3 equation is the third row is equal to the old third row plus 2 into the coefficient of n square. After some calculation, we'll find that the coefficient of n square is minus 4. So the next term of our nth term equation will be minus 4 into n square, and the equation will be 1 by 2 into n cube minus 4 into n square. We are gradually closing to the final equation. Let's figure out the next term of the equation. For that, we need to calculate the 4 rows of 1 by 2 into n cube minus 4 into n square sequence. Here the second row is important because this will be the old second row in our logic number 2 equation. Our logic number 2 equation says that the second row is equal to the old second row plus the coefficient of n. Now we can see that the coefficient of n is 9.5. Now let's update our nth term equation. It will be 1 by 2 into n cube minus 4 into n square plus 9.5 into n plus some constant. We'll figure that out soon. For that, we need to figure out the 4 rows of 1 by 2 into n cube minus 4 into n square plus 9.5 into n sequence. So we get, here we need to focus on the first row because it is the old first row in our logic number 1 equation. Our logic number 1 equation says that the value of the first row is equal to the old first row plus constant. After some calculation, we'll see that the constant is minus 6 and this is the last and final term of our nth term equation. So for the sequence 0, 1, 0, 0, 4, 15, we have figured out the equation of the nth term, and that is 1 by 2 into n cube minus 4 into n square plus 9.5 into n minus 6. Alright, if you are still watching this video, I have to say thanks for sticking with us for the entire time. I know there were some repetitions of a few steps and in some cases maybe I have over explained them a bit, but I think that will help you to remember this process in the future when you will need it. And we have a task for you. If you watched the previous video and also this video, you probably have figured out that the steps and methodology are pretty much similar while finding the nth term equation for this kind of sequence. So your challenge will be determining the nth term of a quartic sequence. Thanks for watching. That's all for today's session. If you have any doubts and suggestions, you can email us anytime. And if you want to collaborate with us on future projects, we will be happy to team up with you. Just mail us.